Welcome to our webinar. My name is Beate Scheibel. I'm Area Manager of Area 3, Process-Based Manufacturing Orchestration.
And my name is Jürgen Mangler from the Technical University of Munich, Information Systems and Business Process Management Group.
So this is the third and last part of our mini-series about manufacturing orchestration engines. And in the last part, we talked about which specific building blocks or tools are available for the specific stakeholder groups. In the last part, we talked about the building blocks for the process designer as well as for the data analyst. And in this part, we will talk about the tools available for the orchestration participants. This could be shop floor workers, clerks, case handlers, but also machines on the shop floor as well. Okay, so which tools are available for these kinds of stakeholders?
So, as you already mentioned, machines and humans are involved because these are the ones that are orchestrating to together produce something. So, let's go to the humans first. Yeah? So, for the humans, basically, two kinds of interactions are available. An orchestration engine is never like an application where you do something in a way that you think is good, yeah? But you are instructed by the orchestration engine what to do next. Yeah? So in this case, typically the result is always a wizard or a list of tasks which are separated and independent that you have to do. Yeah? And this tool is called a work or task list. Yeah? We are as always building everything like very modular. So you can see here that the work and task list, they are split up into a user interface and into a functionality, which is which does the backend and the task storage. So the orchestration engine basically tells, I need this task done, and here is the input that you can use for this task. And typically you also as an attribute tell the task list a role, because one of the advantages that you want to gather is or that you want to use is that don't assign work to one particular person, but assign it to a group of people, and or to a role. So there might be multiple workers, and if one is home because he is like ill, then somebody else does it. But when you assign work to individual people, then you probably have a problem and need the additional thing to do when something goes wrong. So this task work list service is basically a scheduler for the people in a role. And the work is distributed to a group of people. So we need the role name, which group of people, we need what work to do, and we need to give them all the information they need for this task. So the idea is not that this task or work list service, like they utilize data from some other backend systems, but that the manufacturing orchestration engine, in the form of like some tasks which we modeled, first gathers all the information that I need for this task, and then I bundle it into one compound task description. And then I tell this work task list service, please do that. And the purpose of the work task list service is then to distribute it to one person in this role. And there's several strategies to do this. You can either assign it in a round robin manner, or you can assign it to the people, to the person who currently has the least work to do, or you can let the people select the task if they feel like they are up for this task, or you can assign it according to like some other properties. Maybe it's for a certain machine where somebody is an expert, or for a certain customer where somebody is an expert, something like that. So in this work list UI, it's like in an email program, you have individual emails, but in this case not emails, like these tasks that you have to do. They all have their own particular user interface, and you do this. You provide information to this orchestration engine, yeah, or to this running process instance. Yeah. This is typically more used for office-related or information gathering jobs, where you probably need some outside information by a human because you have to do a phone call or something. The other user-related thing is the dashboard service. Yeah, this whole mechanism that I described now naturally doesn't work when you just need a screen in front of the machine where you do something for this machine. Yeah, there you don't have a list of tasks which are unrelated, yeah, and which can be done in various orders, but you just need something done for this machine. Refill the coolant. Yeah, and then some person does it, and some person like confirms that he has done it. So the dashboard service is basically for these other use cases, yeah, which is used for many of our partners. Yeah. These are typically the two patterns which we used in the past for our partners. For example, for our partner EFA GmbH, which has realized multiple worker assistance system, both through task list mechanism as well as dashboard mechanisms. Yeah? So this is how we handle humans. The second thing is how we handle machine interactions, which is basically what I called here generically functionality. So, and you even know better than me how that works because you were realizing one of these particular functionalities for a measuring machine.
Yes, so what I did was implementing a tool that is able to extract information from a technical drawing automatically. And in particular, it was focusing on the dimensions as well as the tolerances and which regulatory documents are relevant for this specific workpiece. And this information could then be integrated into the process information and applied in different use cases. So one example would be that we have an automatic measuring machine, and in combination with this additional data, we are able to automate the entire measurement process. Another use case would be that this information serves as support for an employee that does the measuring manually still. So yes, it was one kind of functionality that was implemented, but what other functionalities are there?
Basically arbitrary things, yeah. So we did, this was an example for extracting the data, yeah, for extracting data from a piece of paper. So the input here to this functionality is basically the measurement, or how is it called?
The technical drawing?
The technical drawing, exactly, is the technical drawing, and the result is all the values from the technical drawings, all kinds of dimensions. Yeah, but other things might apply here, just gathering data from the SAP, for example, or gathering data from any of the other systems which exist in my company. The idea here is not like that you write your own very simple wrappers which do something that you need. Many of these functionalities which are on this operation interface are standard. We can give them to you like the yellow ones, but many of these functionalities, if we work together, we will create for you because they are very custom and they're tailored for your case. Yeah? So another block of functionalities, yeah, is the blue one. Yeah? Of course, very often I just want to access information through some customary protocols on the shop floor. Yeah? And there is protocols like S7 or OPC UA and MQTT, Modbus, or any other proprietary protocol. Yeah? And these blue functionalities, they are very generic. Yeah? They let you query something from an S7 or from an OPC UA or call a method on an OPC UA server. Yeah? So these are building blocks that we need, and we are constantly expanding the protocols that we support, but these ones are readily to be used. Functionalities typically have to create some of my own. Yeah? A last thing that I want to talk about is this high velocity data collection. Up until now on the operation interface, we were just talking about giving the order of doing something. Yeah? But sometimes that's not enough, giving the order of doing something. Sometimes it's about collecting data, for example, from a measuring machine. Yeah? And sometimes that's very difficult. For example, one of the measuring machines we were using had about 12,000 values delivered per second, which is quite a big amount of data. So here we have a specialized component which only deals with high velocity data collection and data packaging. Yeah? Because big data is all well and good, but sometimes it's better to have high quality compact data than just like any data values that don't make sense. So here that's a component that deals with filtering the data and making the best out of these high velocity data streams. And there, of course, we typically internally connect this to an MQTT server, but we have many hardware adapters there. And also we have a connection to the Fledge IoT, which is another standardized data collection framework, which you maybe even have heard about in one of the previous webinar series. Yeah? So I think we covered all of the building blocks that we have available for you. So we have realized multiple or many partner scenarios with the partner in our research institute, but also with partners at the University of Munich. So we are quite experienced in doing that. And if you're interested in working with us and learning more and in much more detail about what we are doing here, or maybe even trying it out in your own scenarios, we would be very happy if you contact us through the social media or other channels that are available to you.
Yes, thank you very much, Jürgen, for explaining this in such detail. This was the last part of our mini-series about manufacturing orchestration engines, but we will continue with a webinar with other topics. So if this interests you, please stay tuned on all our social media channels. Thank you very much.